So hello everyone, welcome all to Physics with Astronautics. And in this video, we will discuss about the elementary particle in the universe, like of the particle physics. Okay, and we'll categorize it into different category based on the interaction, like the strong interaction, the weak interaction, and the leptons, mesons, the baryons. Okay, so let's begin. So first of all, in the universe, we have so many elementary particles, okay, and we have categorized it into two categories based on their interaction, such as the weak interaction and the strong interaction. So under weak interaction, we can have the leptons, okay, and under the strong interaction, we can have the hadrons. So under leptons, we can see the electron, the muon, and the tau, and their respective neutrino and the antineutrino, like electronic neutrino, electronic antineutrino, and such as muon, neutrino and the antineutrino, and for tau also we have neutrino and the antineutrino. Also, you can have their antiparticles, like for electron this is the positron, for mu minus this is mu plus, for tau minus this is tau plus. Okay, then come to the hadrons. Under hadrons again we'll have the two categories. One is the mesons and another one is the baryons. Okay, so under mesons we can have pions, kaons, and eta. So pions are of three types, that is pi plus, pi minus, and pi 0. Such like that, kaons are two types, that is k plus and k 0. I mean this has two particles, and eta has only one particle, that is eta only. Okay, then come to the baryons. Again, baryons are of two types, that are the nucleons and the hybrids. So nucleons, we all know that nucleons are of two types, like one is the proton and another one is the neutron. And we know that inside nucleus we have two particles, that is the neutron and the proton, and these two are only called the nucleons. Okay, so under nucleons we can have the neutrons and the protons, and under hybrids we can have sigma, cascade, omega, and lambda. So sigma has three particles, that is sigma plus, sigma minus, sigma 0. Then cascade has two particles, cascade minus, cascade 0. And omega has one particle, omega minus. Lambda has one particle, lambda 0. Okay. Then come to the lepton number. Like lepton number हर अलग अलग leptons के लिए अलग होता है. Like we know that baryons number are equal for all the elements, like for all baryons. Okay, but lepton number ऐसा होता है कि electronic lepton number, muonic lepton number, tau lepton number. Okay, so we can have three different values, that is +1 for the leptons, -1 for the antileptons, and 0 for the others, like for baryons, mesons, I mean which are not the leptons. Okay, so electronic lepton number we can have +1 for electron and their neutrino, and -1 for positron, that is the antiparticle, and the antineutrino. Okay, so it's like that. L mu can be +1 for mu minus and their neutrino, then -1 for mu plus and antineutrino, and L tau will be +1 for tau minus and a neutrino, and -1 for tau plus and respective antineutrino, and 0 for others, like which are not the lepton, comes under lepton. Okay, then baryons number, we will basically represent it with the letter capital V, and here also we can have three different values, that is +1, -1, and 0. +1 for the baryons, -1 for antibaryon, and 0 for others. Then come to the strangeness. What is strangeness? Like we can have so many strange particles also in the universe. Okay, and basically the strange particle has some values and we'll call it strangeness. Okay, so how it forms, the formation happened with the strong interaction, but the decay happen with the weak interaction. Okay, again we have a formula, that is Q equals I3 plus B plus S whole divided by 2. Here Q represents the charge of the particle, I3 represents the isospin, third component of the isospin of the particle. Then B is the baryon number as we have learned before. S is the strangeness, this strangeness, and 2 is only a number, you know. So Q we know charge. What is charge? Okay. Let's discuss about I3. What is I3? I3 is the third component of the isospin. So first we have to know what is isospin. After that only we can have the idea about the I3. Okay. Then we learned before that Q equals I3 plus B plus S by 2. But here we can see that Q equals I3 plus B plus S plus C plus B dash plus T whole divided by 2. Okay. All leptons and baryons are fermions. So you know what is fermions. That is the third half integral spin. Okay, which particle have. And so here we can see that all leptons and baryons are the fermions. Okay, so here Q is the charge, I3 is the third component of isospin, B is the baryon number, S is the strangeness, C is the charmness, B dash is the beautiness or butterness, and T is the topness. Okay, but in general, we'll write Q equals I3 plus B plus S by 2. Basically, this represents all the properties like the charm, what is the charmness of the particle, and basically we'll see it in the quark. Okay, basically these are the quarks: charm quarks, beauty quark, top quark, strange quark. Okay, then isospin always seen in the strong interaction particles. Okay, पर जो आइसोस्पिन होता है वो हम हमेशा बस स्ट्रॉन्ग इंटरेक्ट जो करते हैं पार्टिकल बस उसी में ही दिखाई देता है. दैट मीन्स इट ऑलवेज सीन इन द मेजर्स एंड द baryons. Okay, then we have a formula G equals to I plus 1. Here G represents the number of particles. Here G represents the number of particles. I is the isospin and 1 is the number. Okay, so number of particle, like which number of particle we are discussing here. For example, we have pions. Under pions, we have pi plus, pi minus, and pi 0. Okay, so pions has 3 different particles. So here G will be 3, and so from this expression, we can have the value of I, that is the isospin, will be equal to 3 G. G equals 3 now. 3 minus 1 whole divided by 2 will be equal to 1. So basically, pions has the isospin 1, and we'll see then what is the I3, the third component. Okay, so I3 is equals 1, 0 and minus 1 for pi plus, pi 0 and pi minus respectively. So for pi plus, this will be 1. For pi 0, the I3 is 0, and for pi minus, the I3 is minus 1. Okay, we saw all these things like what is G, what is I, and what is I3 for pions. Then let's हम इसको एक बार ट्राई करके देखते हैं कि क्या ये फॉर्मूला वैलिड होता है या नहीं. ओके, so for pi plus, we know that the charge is here plus 1, but let's take a test. Like we know I3 equals 1, B is 0, because pions are not the baryons, these are mesons, and that's why here B is 0, strangeness is 0, charmness is 0, beautiness or bottomness is 0, and topness also 0. So by putting all these values here or here, we can have the Q value is plus 1. We know that pi plus has the charge plus 1, and yeah, this equation or this expression is valid here. Okay, so just like that, in further we can have like if in the question they are asking about to find out the value of the I3 or strangeness, आप लोग इस फॉर्मूले के थ्रू निकाल सकते हैं. देन क्वार्क्स, जैसे कि मैंने बोला था कि चार्म, स्ट्रेंज, बॉटम, ये सारे एक एक क्वार्क होते हैं. ठीक है, सो वी हैव बेसिकली 6 टाइप्स ऑफ क्वार्क्स. First of all, the charm. that is represents the charmness. Okay, and this is the singlet particle, like the only particle. So the isospin is 0 here. Then strange. Okay, this is also singlet and represent as here the isospin is 0. Then bottom B dash or beauty singlet. Here the isospin is 0. Then up and down. These two are doublet. Okay, and here the isospin is half. So if the isospin is half here, that we can consider that I3 for up quark is plus half and I3 for down quark will be minus half. Okay, then the last, the top. Okay, the truth or top quark, and which is represented as a T, and this is also singlet and the isospin is 0 here. Okay, then let's discuss about the charge. We have charm, strange, bottom, up, down, and truth. Okay, among all these six quarks, for C, U, and T have charge Q equals plus 2 by 3, and other have charge Q equals minus 1 by 3. Okay, so for C is charm quark, U is up quark, T is top quark. So these three quarks have the charge plus 2 by 3, and other remaining like the strange, the bottom, and the down quark has the charge minus 1 by 3. Okay, remember it. Then the properties. Okay, we have six different quarks. So now let's discuss about their property, like what is the baryon number, charge, isospin, I3, strangeness, charmness, and the beauty and top. Okay, so first of all, we'll discuss about the up quark. So the baryon number. Remember one thing, that the baryon number for all the quarks like up, down, strange, charm, beauty, top, for all the quarks the baryon number is 1 by 3. Okay, and the charge that we have already discussed that CUT have 2 by 3 and the remaining has minus 1 by 3. So you can see here that up quark has charge 2 by 3, down is minus 1 by 3, S is minus 1 by 3, C is 2 by 3, B dash is minus 1 by 3, and T is 2 by 3. That is C, U, and T. These have charge 2 by 3 and remaining has charge minus 1 by 3. Then the isospin. We know that U and D are doublet, and that's why here the isospin is plus half and minus half, and remaining have the isospin 0. Then I3. I3 for up quark is plus half and down quark is minus half, and remaining is 0, because we know that isospin varies from plus I to minus I. Okay, and that's why these are 0. Then the strangeness. Strangeness is 0 for up quark, down quark 0, and for S, this is the strange particle is minus 1. Remember this is not 1, this is minus 1. Okay, for charm this is 0, beauty this is 0, top this is 0. Then charmness. Charmness is only 1 for charm quark. Okay, and for remaining this is 0. Beauty. Beauty is minus 1 only for the beauty quark and 0 for the remaining. Top is 1 for the top, and for the others this is 0. One thing remember, strangeness has the value, strange quark has the value minus 1 as the strangeness, and beauty quark has the minus 1 value for beauty quark. Okay, but charm and top has charmness 1 for charm quark, and top quark has topness 1. Okay, as I have already told you that we have other particles too, elementary particle. So one of this is the quadraplates, and these are delta plus plus, delta plus, delta 0, and delta minus, and all this comes under the baryons categories. Okay, so you can see here the four particles. So G will be 4, and so I will be G minus 1 by 2, that is 3 by 2. Okay, so here the I value, that is the isospin value, will be 3 by 2 for the quadraplates. Let's discuss what's next. Like mesons. We have discussed the properties of the quarks. Now we'll discuss the properties of the mesons. Under mesons we have pi plus, pi 0, pi minus, K plus K0 and eta. And K minus is the antiparticle of the K plus and K0 so. Okay. So Q value is 1 for pi plus, isospin is 1, I3 is 1, strangeness is 0 and the formation is U d bar. Then like we have U, U has the charge 2 by 3 and D has the charge minus 1 by 3 now. And here D bar. So this is 1 by 3 only. So 2 by 3 plus 1 by 3 equals 3 by 3 and is equal to 1. So here you can see that pi plus has the charge 1 and that's why the formation is U d bar. Okay, then pi 0 has the charge 0, I is 1, I3 is 0, S is 0 and the formation can be U bar or D bar. Then pi minus 1 charge, isospin is 1, I3 is minus 1, strangeness is 0 and Q bar is U bar D. Then K plus, the charge is 1, the isospin is half, I3 is half, the strangeness is 1 here and the Q bar is U S bar. Because we know that S bar has strangeness, S has strangeness minus 1, that's why S bar has strangeness 1. Okay, here you can see. Then K0 charge is 0, I is half, I3 is minus half, uh, strangeness is 1 and the formation is S bar T. Then eta 0 0 0 0, you can say that U bar S bar D bar T. Then K minus and K0 you can see. Okay, you can calculate it by yourself also, like if you have the knowledge of the sign here. Okay, then come to the baryons. Under baryons, we have so many particles like proton, neutron, cascade, sigma plus, sigma 0, sigma minus, cascade 0, lambda 0, omega minus, delta plus plus, delta 0 and delta minus. Okay, so proton has the charge 1, isospin is half, I3 is 1 by 2, S is 0 and the formation is UUD. Like U has the charge plus 2 by 3, U has the charge plus 2 by 3 and D has the charge minus 1 by 3 and that's why this is 4 by 3 minus 1 by 3 is 3 by 3 and equals 1. The neutron Q is 0, I is half, I3 is minus half, S is 0 and the formation is DDU. Then uh, sigma plus Q1 I1 I3 1 S equals minus 1 and the formation is UUS. Then sigma 0 0 1 0 minus 1 UDS. Then sigma minus 1 1 minus 1 minus 1 DDS. Cascade minus 1 half minus 2 DSS and so on. You can see below. Okay, by pause the video, you can pause it. Then, and so that's all for this session. So for more videos, if you like my videos, please do like, share and subscribe. Okay, please do like. Thank you.